So, hello everyone. I am Sayyid Ikramuddin Kirmani, and welcome to day one, our cloud computing series, where this series just isn't about posting notes on LinkedIn. I am going to explain the concepts and share how I am learning them and how and show you real time what I am applying them. Okay, so basically I don't believe like just diving into AWS. I just believe I have to learn some basics, so I'm going to first learn basics. So today we'll start with the basics, and the basics starts from like what we are going to learn today is operating system. So in that what we are going to cover, like what is operating system, second types of operating system, third multitasking versus multi-threading, and the fourth components of operating system, fifth system calls in operating system. And if you ask me like where I am going to learn from this all operating system and all basics and all, so firstly I will tell you that I'm not that person who's just like to buy courses, like high like buying higher prices courses and all. So I always believe the internet's free, so you can learn from there. So YouTube is also a good resource where you can learn anything. So there is a love bubble YouTuber where I am going to learn operating system. So he's explained very well about operating system. So I will first show you where I am going to learn operating system. So on YouTube you have to just search it, love, yes, love bubble OS. If you just type it, then you will see this playlist. You have to just take this resource as operating system. They explain very well. So I am going to learn from this playlist. So I'm not going to show the whole video and all. I'm just explaining what I have learned from this. So I'm going to first make notes, and that notes I'm going to explain you. So I have created notes, like I have see 5 videos a day. So in 7 days I'm going to complete this operating system. So let's start with operating system notes which I have made. Where it is? Okay. So operating system. Okay. So I'm just not going to say what is operating system. Firstly, uh, let's understand why operating system is important. Let's suppose we have a TikTok, okay, and if we have a resource like CPU, memory, GPU, disk in your mobile, okay, in your mobile or whichever device you have. So what is if there, let's assume there is no exist right now operating system. So what TikTok will do, TikTok will hack full your device, like using how. So TikTok, what we do, TikTok will take full CPU, full memory, full GPU, full disk. So in that case, this system in your device, like going to hack, like it's like a, like I have said पूरा hack कर लेगा, like that. So and I have also said पूरा resource ले लेगा OS नहीं रहा तो. Okay. So if you want to like now if you want to run your PUBG also, so it's not going to run because of it. TikTok has take all the resources. So now the operating system come in the picture, and it acts as a interface. So what will happen, TikTok not directly talking with the resources or like hardware, TikTok will talk with OS layer. So in that OS layer, what they will do, he is saying about TikTok like, don't be a mafia, take, I'm going to give you this amount of, and you have to work on this. So according to the TikTok, OS layer give the CPU amount, memory amount, and GPU amount. In that way, now you can run PUBG. Otherwise, if there is no OS, then TikTok, you can't run PUBG. So that is the importance of operating system. So now you have understand the example to have explained. So operating system have two. So firstly, if you see, there is a resource management is happening. If you see, because TikTok has given CPU 5%, 10%, 12 GPU percent. So in this view having, if you see, so it's having a resource management. Indirectly it's giving a resource and it's managing. So what exactly operating system is doing right now is resource management. And if you see second, I'm come to after this, but I'm going to explain you after this second. Firstly, I will tell you OS work as an interface. So what, having, take an example, you have a account in a SBI, okay, and you want some money like 1000. So you are just going to bank and say, cashier, going to say, directly say, cashier, I have to take this amount of money, so can you please give me. So what cashier will do, cashier will go and from your account, he will take some amount of money and give it to you. So in that, cashier is like acting as a interface, if you see. And you user like we, like users, okay. And what this amount of, he's not giving full amount of yours, he's giving some 10k, if you want 10,000 or anything, like if he, there is a 10 lakh, but there you have only amount of 10,000, so he's going giving on that basis. So it's like a resources. So if you understand this example is very well. So I think now I'm going to explain this second point, bulk app nahi honga. So what is basically means, if OS is not there, then what will happen? TikTok, if some developer is building TikTok, or some developer building like PUBG app, like application, so he has to first write memory management code and resource management code. Exactly, PUBG developer has to also have to write that this code. So in that way, your app becomes bulky, because your app only is having 20 MB or 50 MB, but 700 MB takes of resource management and uh, like memory management. So it takes 700 MB. So in that case, it will, your application will become bulky. So what operating system do, it store in their database, like you don't, developer has don't take care of resource management code and memory management code. In operating system, there is a code available, the management code, resource management code, and memory management code. So you have to, like you don't have to take care of them. So it's like a dry, do not repeat yourself, it's like that, if you exampling that. So I think, so this second statement is saying your app will not be become bulky because of OS. If you understand, if there is no operating system, then what will happen, you have to write this all the code into your application, and then it becomes bulky. So to avoid this, operating system come in this picture? Because operating system, there is a save that core resource management code and all. So now we will learn going to learn isolation and protection. What is it is the basically means. Now if you understand uh, what system is doing, TikTok also running in the same device and PUBG also running in the same device. If you taking example, if you are playing PUBG and there is a health, player health is 100, but if TikTok overrides and writes and write 0, then what will happen? The player will be die in that game. So it will be a like a not good, and it will be a disaster. So what operating system is doing, it's giving memory resourcement, like memory and everything, CPU and everything, but TikTok doesn't know that they are working on a same device, and PUBG also don't know they are working on a same device. What exactly operating system is doing right now? There is a memory. So 1 to 12 TikTok has given allotted, and there is a 15 to 20 take example. So in that case, there is a part, there is no like a connection, so they don't know. And in that case, TikTok does never going to override PUBG, and PUBG never going to override TikTok. So operating system gives you isolation and protection also. So what is the goal of operating system? First, maximizing CPU utilization. In if you like idle नहीं बैठेगा, like idle नहीं बैठेगा मतलब, if you see this is a CPU, okay, P1 P2 P3. What is P1 P2 is process 1, process 2, process 3. So what P1 doing something work, and he has something out, have to do output. So in that case, he has some left work, but he has to go for output. So what P2 will do, what OS will do, in that meantime P2 has allotted that CPU. So like in that situation, CPU maximum utilization happening. If OS is not there, then what will happening? P1 doing their work. After P1 complete their work, full code will run, then is their output have to in that code, there is an output have to do. So it's go for output, showing output. After it came, so in that time P2 and P3 has to wait. But if OS has there, then we the goal is like maximizing the utilization. So it basically saying that P1 and like P1 has to first complete, if go output, then OS will do allowed CPU to P2. Okay, after that, second goal is for operating system is to process starvation not happen. Okay, so नहीं होना चाहिए. Why I'm saying? Because if there is a like process 1, process 2 and process 3, okay, in P1 there is an infinite, like developer has written some wrong code, and that code has like in that P1 it's going infinite. So what happen? P2 and P3 will always be in infinite waiting. So this never happen. So OS has to care, and we will learn like learn other day what going to happen. So I will then I'm going to tell you what will exactly operating system do. So this thing not happen, so operating system has to take care of this also. After that, if like high priority execution, what exactly it means? Like if P1 has a some work, he's allocated, but P2 has a important work. So what, according to priority, what operating system do? Operating system allocates CPU to P2 process 2. So you, these three goals operating system has to take care. So now we will dive to types of operating system. So first is single process operating system. In this, single job run, not multiple job. What is saying? Only P1 first will happening. After that, P2 can allocate to CPU. So in that, if you see these three, you have to remember these three goals. What if you remember? You have to remember these three goals: maximum CPU utilization, process starvation नहीं होना चाहिए, not happen, and high priority execution. These three you have to goals you have to remember. Okay, so in this, have you can you see in this maximum CPU utilization is not happening, right? And process starvation also is happening. Can you say, well, and now you can ask how? If P1 is in have some error in their code and it's running infinite, then P2 and P3 will be waiting for infinite. So in single process operating system, there is no CPU utilization, maximum CPU utilization. Process starvation is happening, and high priority execution is also not happening. So CPU one, like single process operating system, is not good, like it's older version. And batch processing, what batch processing is to actually do, if you see, it's first create a card like a digital information, then it's operate like a jobs. So what it's do, it's like a sequentially execute uh, like a job, like for what can I say, if job 1 and job 1, job 2, and job n, okay, and user 1, user 2, there is so many, okay. So what will happen, sequentially is executing, okay, but in this, maximum CPU utilization is not happening. What you, if you see, job 1, like it's creating batch, okay, batch job 7, job 5, job 2, in job 2, okay, in batch 2, and in batch 1, what is job 4, job 1, okay. So in this, it's not there is no sequence is like sequentially is executing, but it's happening in a batch 1 and batch 2, okay. So there is, like, if there is also a not your maximum CPU utilization, process starvation is also happening, because if this batch 1 is in a loop, if like job 1, job 4 has a infinite code in their, like in their process, then uh, this batch 2 has to wait for infinite, and job priority also not executing, because it has to wait first. If its batch 1 has to complete, then it's, so in this also this all three is not happening. Now we will come to multi-program. This is important, okay. If you see, it is a single CPU, okay, it's work on a single CPU. So what is doing, job 1, job 2, job 3, job 4, okay. This is the important because in this, there is uh, happening context switching. What context switching means, if job 1 has to have a some IO, like input or output have to do, then content switching means job 2 will allotted to CPU, uh, CPU allotted to J2, okay. So like I have said, PCB, we will learn afterward. We will first going basic. When we come to this PCB, we will learn what is. So PCB, what is, process control block, okay, प्रोसेस कंट्रोल ब्लॉक, ये डेटा स्ट्रक्चर है, ये डेटा स्ट्रक्चर है. व्हाट इज मीन्स, लाइक इट्स सेविंग P1 has going some IO, So you can like it's storing like this p1 has gone and is storing like p1 storing in this PCB, and it's allotted to this. When P1 J1 come to the back after IO, then PCB going to work and restore that, and CPU once again allocated to J1. So in that case, there is a context switching. So you will basically understanding that there is a maximum CPU utilization is happening. Okay, and in this you can also see starvation is not happening, and there is a content switching, so that's why. But there is a starvation is there in this, we can say that. And now we can learn multitasking. So multitasking, what is it? It's also work on single CPU. Content switching is happening. I explain you what content switching. Like content switching means basically give allocated. If J1 is going to going some IO, so then CPU allotted to J2. It's basically that. And J1 going when J1 is going to IO, then it's going to firstly save first in PCB, then it's going to IO. So what's happening here? So when J1 comes back, then it's restored. Okay, so there is a content switching is also there in multitasking operating system. This is the fourth. This is also important. But in this there is a time sharing. There is a time sharing. So what is time quantum? Quantum means like a 1000 milliseconds. So what is in this happening? P1 has some running some for 1000 millisecond. After then P2 running for 1000 millisecond. Then P3. So there is a time sharing. So after 1000 millisecond, P2 allocate to CPU allocate to P2. After 1000 millisecond, CPU allotted to P3. So in this, maximum CPU utilization is happening, higher priority is happening, and starvation is not happening. If you ask me how it's not happening, if you look at this P1, if there is a error in your code and it's having infinite, but there is a time sharing. So in that way, if there is an infinite in your P1, then also it's not going to affect its CPU allocate to P2. So this is happening. So starvation is not going to happen. And high priority, if like it's going to happen, if like millisecond happen, what will, if this P3 has a 9000, so it will allocate to CPU allocate to P3 like that. Now we are going to fifth operating system, and that operating system is multiprocessing. And this is like you can see there is content switching, time sharing. Now you understand what is time sharing. Time sharing means like there is a time has given to every process. Like if P1 has to have completed some like input output, everything is completing, CPU allocated to 100 millisecond for P1, then P2 allocate CPU allotted to P2 for 100 millisecond or whichever. So you can understand, now you have understand time sharing. Now this is important because multi CPU. Okay, this is multiprocessing operating system working on multi CPU, not on a single CPU, which we have, like we have learn this like single process, it is also working on a single CPU. Batch processing operating system, it is also working on a single CPU. Multi programming, it is also working on a single CPU. Multitasking, it is also working on a single CPU. But in multiprocessing operating system, it works on a more than one CPU. So in that case, there is like P1, P2, P3, P4, so on. Okay, there is process are there. So what P1 and P2 allocate to CPU1, P3 and P4 allocate to CPU2, and there is no starvation, there is no time sharing, like there is no starvation, maximum utilization is happening, and higher priority, based on higher priority it's will allocate to based on that. Okay, so we will going to learn how it going to like based on higher priority operating system allocate CPU to that process. We will learn going to learn that also. So we have to just wait for that. So firstly we have to just cover this. So distributed or like we are on sixth, distributed operating system, or we can say loosely coupled. If someone, if you are in an interview, if some interview asked you, can you tell me about loose coupled operating system, so you have to don't panic. It's basically asking distributed operating system only. Okay, so there are two names. It's called loose couple also or distributed. So in this what happening, it's like there is operating system. Okay, CPU memory and there everything is there. So what operating system do through internet is it's going to go, happening on through internet. Okay, so what it's going to do, operating system allowed this high GPU, like based on your process it will be given that memory and all. Like P1 has P1 has some high GPU work and all. So what operating system will do, distribute that CPU1 P1 to the year, P2 to year, P4 to year, like that. If you see um, like here is a GPU. This memory is a high GPU, this is a low process. So based on their priority, based on their like what can I say, based on their based on their CPU high utilization or memory high utilization, based on their they will distribute like this. Okay, so it's like example I have written online code editor. Okay, seventh we will learn RTOS. What is RTOS? Real time operating system. Basically is I have written also errors chance बहुत कम होते हैं. Like errors chance कम होते हैं, like means it's not like there will be a error in this operating system. Why? Because it's running in a air traffic control, because it's real time execution, like real time execution होते रहता है within a second होना चाहिए, विद एन एरर फ्री, इसलिए RTO यूज करता है. ओके, so it's like a so now we can like examples like single process MS DOS, batch processing Atlas, multi-processing THE, multitasking CTSS, multi-processing Windows, and distributed locus, real-time operatings. I have said you air traffic control use this. Okay, now we will learn what is thread and process. Multi-threading. In that we will first learn what is thread and process. If you like code, there is a code prime number code लिखा है C++ में. ओके, सो टेक्स्ट इसका एक्सटेंशन C++ होता है. इफ़ यू नो दैट C++, कंपाइल एग्जीक्यूटेबल टेबल बनता है .exe की बोल के विंडोज़ में. सो व्हाट इज़ हैपनिंग, इफ़ यू double click on that process, like what is process, program under execution. What you will learning from, like what you understanding from this sentence, It's basically saying there is a program in this. It's come from, like taking from, and allocated to RAM, and something happening on that work, or like something execution is happening, so that is called process. Okay, now I'm going to repeat. Program is in a disk or RAM or memory or what in your C drive, or when you run a code, or you take out from disk and allocate that program, RAM allocate to that program, and something happening on that program or a code, that execution is called process. सीपीयू तभी काम कर सकता है जब प्रोग्राम रैम में आ जाए. Okay, now you understand. When RAM or CPU, when it's running, when program is come from disk, disk to RAM. Okay, इस that's why I have written CPU तभी काम कर सकता है जब प्रोग्राम रैम में आ जाए. जब लाइक .exe पे डबल क्लिक करते हैं तो वो रन में आ जाता है, तो इसका हम बोलते हैं प्रोसेस, इसको बोलते हैं हम प्रोसेस. ओके, इसको हम बोलते हैं प्रोसेस. इफ यू क्लिक दैट डबल प्रोसेस, देन इट विल बी execution is something, so that will we will call this process. So in simple words, program come from, took from, and like allocated RAM allocated to program, and something happening in this, so that process, that thing is execution is called process, simply. So now we will understand. Now you understand what is process. Now we have to understand thread. Thread is nothing, light-weighted process. Light-weighted process, what is meant? Independently execute होता है. Okay, independently execute होता है means what? P1 और P2 को नहीं मालूम रहेगा कि वो execute हो रहे हैं, like that. User input, process show display. User ने input डाला, user have some give input, and storing it's storing on cloud also, and it's showing display on your, like showing on your display. So it's happening, two process running on same times. Main process and subtask, it's like a subtask. क्लाउड में लिखने का वो थ्रेड करता है, ये इंडिपेंडेंटली इसका यूज़र पे इंडिपेंडेंट नहीं है. मतलब इट्स बेसिकली सेइंग like this storaging in on cloud, it's like a thread, because main it's showing your input on your display, processing and all, and this in the background it's storing that. So it's basically main and subtask is working, so it's like a thread. So now I will give you from, I will explain you from example. If you convert PNG file into JPG, so what will happen? First A B 10 second लेंगे logically. A B, फिर A फिर B sequentially होगा. Okay, so what threads do? 10 second तो लेंगे thread 1 thread 2, it directly giving like simultaneously work कर लेंगे, parallelly work, it's working parallelly, like that. A1 A2 allocate to the CPU, and it will be parallelly working. Okay, I will give you one more example. There is a process one, so there is a subtask T1 T2, like subtask like thread 1 thread 2 thread 3 thread 4, like it's a task, it's a process. If you divided that process, that will become thread. If you, I will give you example. If you are like using Microsoft or typing anything, if you are typing anything, so you are giving input through a keyboard, so it's typing. and showing, taking as an input. Okay, it's taking input from a keyboard and it's showing words to you. So it's basically like simultaneously working that process. Typing is also happening and it's showing to your displays, so these two processes showing to you simultaneously. Okay, working. If you see multitasking and multi-threading, okay, I will for like, I think I have not given much like explaining thread. I will explain in Hindi for 2 minutes. So what will happen, it's like you are working two process, you are working one process, and in that process sub task is there. Like if I am recording, okay, okay, I'm taking this example. I'm recording, screen recording, but in the meantime also it's recording also, um, it's recording, I'm recording myself also. Okay, if okay, ये रिकॉर्डिंग हो रहा है, स्क्रीन रिकॉर्डिंग भी हो रहा है, वॉइस भी हो रहा है, और webcam like my, I'm also seeing like it's showing me also. So it's happening multitasking. It has a one process, but it's having subtask. Okay, so it's doing this like showing in this video. So it's having a one process like sub thread, and the recording, screen recording is a one thread. So voice recording is a one thread, is a thread. So this comes in a one process and subtask is divided, that is a thread. Okay, so now we will discuss multitasking and multi-threading. So what is happening in multitasking, process more than one process more than one process concept, it's like that. And in more than one threads, what is happening in that, one or more process will work. Okay, and in what is happening in that, only one to two, like one to or more threads will work. So in that isolation and memory protection will be happening. But in thread multi-threading there is no isolation is there, because if you see there is a task, it's a process in it's a process, thread 1, thread 2, thread 3, so it's allocated to that PC only. So it's sharing that resources of that CPU or memory on that allocated, it's using that storage only. But in multitasking, if you see this process doesn't know they are working in on same, but it's having a partition. If you I have explained you that on TikTok. If you see in this example, it's like a multitasking, it's working on same device, but it allocated isolation. TikTok doesn't know PUBG is also running on the same device, and it's have a isolation and protection. So what is saying in that only, isolation and memory protection will be there in multitasking, but in multi-threading there is no, because if you see it's using one resource, one CPU, one memory, one everything, and it working on that only. And then okay, and process schedule means process 1 CPU के पास हो जाएगा और P2 CPU 2 के पास हो जाएगा. It's like process scheduling, like P1 process uh, के पास हो जाएगा, P2 के पास हो जाएगा, like that. Thread scheduling means thread 1 CPU, like thread 1 will allocate to CPU 1, and T2 allocate to CPU 2. It's like that. Now we will understand the components of operating system. First, there is, if you see, there is two main components: user space, app are run here, kernel space, we don't know. Like I am using this screen, I don't know the what is happening in my laptop and all. what actually hardware is working and all. So that is the kernel, like access to underlying hardware. I don't know what is happening in my laptop, or like what is the hardware working and all. I just using this interface like this, so I'm accessing that hardware. Okay, so it's like that. So user space and kernel. Okay, so user space means no hardware access, only convenient environment user app provide, like Windows on, like I have on window. So in that there is a CL command, like command line interface. In that there is a terminal, or we can say PowerShell. Okay, what I can do, I can, if you know this command mkdir, what it's make it, what this command actually do, it's make new folder. If you want to make a folder, you have to say mkdir, and you have to write that name of that folder. So it's build that folder, create that folder. So if you're not dealing with, you're not like you're using user space. So with user space you are using CLI command, or your GUI you are using. So you are using this command. So what exactly MKI going to do, it's calling internal system call. Internal system calls करता है. Internal system calls में, like in a laptop it's calling internal system to operating system, storage management, like there is a store, like storage management जो में जाओ, फाइल मैनेजमेंट में का काम है बोलता है, फिर उसमें डायरेक्टरी बना दिया जाता है, like that. It's like making going underlying hardware and giving commands, like you have to make this file. So it's go to storage management, then storage man said okay, I will store this amount of that, and will file go file management and all this will happening. Then it shows you to the that folder. Okay, if you see mkdir, we have used that command. So it's called system call. This call to the system calls deals with underlying hardwares. It deals with underlying hardwares. It's going to call and giving them commands like storage management, you have to make this file. So you have to take this amount of space and all. Then it's call okay, I will do that. Then it's going to the file management, you have to store in this directory and all that, like that. You have, if you will learn this also. So what it exactly this command is doing, it's calling system calls, and system calling, so this, and then we will show that folder in our screen or display. So user space is like we are using some CLI command and like something, and in for if you are using this CLI or power terminal, PowerShell, anything, what is it's like, this is this is user space. If you clearly understand, CLI is a user space. If you analyze, you are just not dealing with like going to uh, like doing C hardware and all. If you don't know, you just giving a command, I want to have this folder, I want to make this folder. And so what user space is giving command to system calls, and system calls having this all the works of what we want and showing us to. So we have use command mkdir, then it's calls, then it's make like that folder, and it's showing to us back to on our UI GUI use. Okay, UI, if you can say also UI. User space interacts with. So if you see in what this sentence is saying, user space interacts with kernel. Okay, I'm if I want to access or like interacts with kernel, so I have to use user space. And what is user space? If you have like anything CLI, PowerShell, or anything you can, like you are dealing with like a hardware, so it's like if you are using that, it's like it's a user space. So now we comes to kernel. So kernel is a heart of our operating system. It's main, it's important also. So what it's doing, interacts with hardware. So it's directly interacts with hardware. Okay, so we have run the command. So system calls. So if you see this internal system, so it's basically system calls we will learn further. So system calls to the kernel, or we have this command, we have this requirement, can you please uh, uh, do this. So what kernel do, uh, go to that hardware and say, oh, this command has run, can you make this file and all. So hardware, okay, then I will do that, and now hardware make that folder and all. It shows back to the kernel. Kernel will shows to the system calls. There is a system calls layer, so it should going to show there. Then it is displaying to us UI that your folder has made it. Like example, hello world.sh. Okay, is a PowerShell. It's a shell script. If you .sh means it's a shell script extension. Okay, so what functions are there? Kernel space, process management, memory management, file management, and IO management. Okay, so first we will understand what is process management. What exactly kernel space are doing with hardware. Okay, process management, what is going to do, like I have commanded mkdir. So what will happen, the process will come, process will creation or termination. If created, okay, created. Yeah, if I have like mkdir delete or anything, I have done that command, then it will be a termination that file owner. And process and thread को schedule करता है. Okay, and process synchronization is also happening. Process communication, if you see that p1 p2 have a communication through kernel, like in this process management. Okay, so what exactly, if you understand that kernel can have do this four things. So in that four things, like he can do creation of files or termination of files, process and thread push, like the process and threads are can schedule by kernel, process synchronization by kernel, process communication going through kernel. Few process have to communication, we will learn further how process communication with each other. Then we have a memory management, how to allocate, how much like have to allocate and all, and how to delocate. If you run that command, it's like users, we have command, then kernel going to do this all these stuffs. Okay, free space management and all. And file management, create delete file, directory management, like if I have lecture and operating system, like it's like a directory. Okay, if you see like IO, like input and output management, like if you see like I have give some input, make file, then it give create that file and giving output to me that you have created your file, like that. Spooling, buffering, caching, we will learn further afterward. Okay, so types of kernel. So we have to first like learn types of kernel. So there is a monolithic kernel. So in that's what's happening, process one. And in this one, in this what is happening, user space, and this is a kernel. In this there is a process management, memory management, file management, input management. So what is happening, everything is has in this only. So if this if this damage, then all the system will be damaged, like that. If you has a user mode, okay, kernel mode. Okay, this is user mode and this is kernel mode, like that. Okay, if you have a cl command, make mkdir like this file. Okay, enter. So what you will do, file management and make a directory and make giving output back that you have made it this. Okay, software interrupt, we will learn that. Software interrupt means like like if we have created and this going to this, it's software enter. Okay, fast communication between different components of kernel. Like you have create, like you have just command and is make that a process and what you have to do to run the command, and is done. And through software interrupt, it's giving that notification or communication through software interrupt. It's basically saying that fast communication between different components of a kernel. Okay, if you see process memory file, what is saying it is they will have a fast communication in this kernel. Okay, why? Because they are in a same, and so because of software interrupt they will have a also like a fast communication different components of kernel. Okay, so less reliable, kernel bulky है, कर्नल बल्कि हो गया. Why कर्नल इज बल्कि? बिकॉज ऑफ प्रोसेस मैनेजमेंट इज here only, memory management here only, file management here only, and input management here only. All these are four things have in one place only. That's why kernel's bulky here. And less reliable. Why it's less reliable? I have said you before, if this is happening like this is have giving some error, then this whole thing will be have an error, have show error. So it's less reliable. So is example Linux and Unix and Mac or DOS. Okay, MS DOS. Okay, this example this software, this monolithic operating system used by Linux, and this is the example. Okay, now we will learn microkernel. So what is microkernel? This is okay. There is a upright user space. After that, this is the like this is the, if you see, this is the user space. In this space you can do file management and input output means it's showing you on your display. It's and file management happening on your like a display, like it's divided these components of kernel. File management and output have has now in user space, and kernel space having memory management and process management, CPU and RAM, and file management output having an user space. Like this thing is good because input output you have to show in this, it will be a grid, and file management also a grid. So this is a grid, so it's less bulky because of divided of kernel's components. Like if you see file management and IO has in user space, and in kernel space there is memory management and process management are. So in this way it's less bulky and more reliable. If this fail, if this fail, then also this will be work. If this fail, then also this will be work. So it's like advantage of this: stable, more reliable and less bulky. Disadvantage: performance lens, because overhead. If because of like you have to give P1 have come and have do some work and has to do IO, so here has to go again on this user space. So this overhead is a disadvantage of this microkernel, because of users mode to kernels mode, mode to user space mode. So in this way it affects the performance. So this is the advantage of microkernel. It's example of L4 Linux and this operating system. And interview, if you I have written this interview question: if how user mode and kernel space mode will communication. So there is a like one PC inter process communication. So in that what is happening, they will using communication through directly, or they will communication with through shared memory, message passing, or a shared memory. Shared memory means like there is a one memory, it stores something here, P1 stores something here, and P2 can access that and communicate that process P2. So in that way they will uh, communicate. Or second way, we can directly pass message through message passing. Okay. And here we are now. Third, this is last. Okay. Third, hybrid kernel. So what is hybrid kernel is doing in that combined approach. Okay. In space there is only file management, and in kernel space there is process management, memory management, and input output management. So in that way there is it's less bulky, it's more reliable, its performance is also good. So it's example of Mac OS, Windows NT 7 plus, after that 7 plus generation of Nano and Excel kernel. Like if I am giving this as the example, we will learn after that. So now we will come the important topic, what is system calls, and this is the last. So I'm before I'm always telling you there is a system call. If you have to communicate with kernel space, and kernel space has to communicate with user space, there is a system call interface. System call. So system calls interface. It's calls. There is a layer. So what is happening? If you have a aim to create a directory or new folder, so GUI, like you have creating a new folder, and that folder name is movie, and you have clicked that button. So CLI CMD, there is a command mkdir. So what is happening? You are using this GUI means user space. You have command, run the command. So first it calls to system calls. If actually implementation, if you see mkdir in a C. Okay. So system calls C. Okay. Process hello world.exe, run system calls, and switch, km switch, process management. If you see, user space calls to first system call interface, then it will show that this command has user has run. So system call, what he will do, he will communicate with kernel space that this requirement has come, you have to we have to run this process one or anything. So that in that kernel space doing that work, then what will happen after completing that work or process, kernel space again contact with system call interface. In that interface, output will given to, like kernel space give output to system call give output to user space. So it's like a system call. It's if you have to communicate, or like user space have to communicate with kernel space, and kernel space has to communicate with each other. So you have to use the system. There is an interface, or there is a layer in between, that called system call interface. Okay. If you see the example, the switch and the process management have create process and all, then execution is and software it I have explained you. So today we have learned this all things. So I hope you understand all the concept what I have explained to you. Now we will meet tomorrow with new topics, new concept. So I think I hope you well understand what is operating system. And my main aim is to not just posting these notes. My aim is to explaining this note, because if a recruiter or HR, if anybody is on LinkedIn or anyone, if you see other candidates or other person, they only posting these notes. So how the HR and how the company, or how the recruiter know that you actually learn this? You can post whoever's notes. So to make sure that I have learned this, and these notes I have made, and how I learned from that playlist. So I want to show, that's why I'm recording and uploading this video on YouTube, so that can recruiter and HR or anyone can see my thoughts, what I have understand from these and all. So I want to outstand from other candidates also. So you have to be a like extraordinary, or you have to be not like ordinary peoples. If you have to like the market is not, you have to be competition is much, so you have to become do very well. So this idea have come, then I have implemented, and I am going to daily upload my cloud journey achievement and all. And like I'm say I'm going to learn first basics. So what I'm going to learn operating system first, and second I'm going to learn computer networks. So what it will happen if you l- learn these things, you actually going to have a like you can easy on AWS, because you know how the operating system works and computer networks works. Then you will it easy for you to understand AWS services on services and all. So yeah, that's why I'm not just directly diving into AWS. Firstly, I'm going to first learn operating system. After that, computer networks. After that, I'm going to learn uh, AWS service. So I hope I have done today's session. We will meet tomorrow. Till that time, have a great day. Okay, bye.